So I'm going to be doing something a little weird today, a little unconventional. Most people would call this an airless paint sprayer. But what an airless paint sprayer is a high pressure electrically operated hydraulic pump. I hook this up to my 20-ton arbor press. With this driving the hydraulic cylinder of the 20-ton press, then it's kind of like having an arbor press. And up it comes to right around 3,000. That is proof of concept that the idea is going to work. So now all I have to do is modify the frame so that the jack can be bolted in upside down. So in the original incarnation of the frame, the jack sat upright, the jacking point went up in this circle, and all the pressure was applied against these upper beams. What I'm going to be doing differently, of course, is I'm going to have the jack inverted and bolted essentially to this flange. So step one is to cut these welds and get this plate off of here. Then I will take some, I know I have some 3/8 plate, I may have some half plate, and cut it to the shape of the jack base. Drill and tap the plate, attach the jack to it, invert the whole thing, line it up on center, left, right, front, back, and then do one session of welding of the plate to the beams. So I've cut away the weld on both sides. I just used a Sawzall to slice these under welds. Put a chisel right there, and one hit with a chisel and this end popped free. There we go. And off it comes. The weld on this edge just snapped after having cut all three other sides. So it turns out that the plate that I have handy is just the right width to completely support the pressure part of the base. So I cut it off, and using the bandsaw, I cut it off, rounded the profile to match the front profile of the jack. In the back, I'll leave the sharp corners because I won't be working around the back, so I don't really care about the sharp corners back there. But up front, I don't want any sharp corners to hit against. I have drilled the base of the jack 4 locations, 5/16, and I will center punch these, drill and tap them so that this jack can be attached to this base. Okay, so I have the plate cut out and tapped so that it can be bolted to the base of the jack. I've done some measuring. I found the center of the cylinder. I located the center of the cylinder on the center of the frame. This is center to center, left and right, center to center, front and back. And I have a single locating hole here where I drilled all the way through and let the bolt screw all the way through. So I'm set up now. I have V'd out my steel for where the welds will be at. Obviously cleaned off any paint and scale. And I currently have it under about 2,800 psi, which is making the thing firm in its final location so that when I tack this plate in place, it is oriented fully the way that the plate is going to be oriented. It's not tilted, it's not cocked, it's under pressure of where it wants to settle in when it's being used. So I will tack this and then weld it. So there it is after welding it up and applying a little bit of the closest orange paint that I had on hand. The welds are fully 1/4% better than whatever was done originally, and I'm very proud of that. So now that I have the jack inverted and working, bolted in place, and I have the proof of concept that the pump is going to work, now I simply need to adapt. I need to adapt this output fitting to this input fitting, which is the same fitting as the paint hose. And I need to adapt this input tube to this hydraulic reservoir output. I think what I will do is actually screw a piece of 1/8 inch brass pipe in here and basically use that as a barb. And use some air hose, regular 1/4 inch or 3/8 inch neoprene, 100 psi air hose. Then all I need then is a way to attach the air hose to here with an airtight seal, a vacuum tight seal more to the point. And to do that, I think the easiest thing to do is to take this piece off, mount it in the lathe, and give this some kind of a female thread. I think it's going to have to be a 1/2 inch NPT. I could just bore something to this diameter and use this O-ring seal as it sits, but that's going to be a fairly large piece of material. Anyway, I'll choose a way. And then I also finally need to choose where to put the pump. In a perfect world, I would mount the pump in this cavity right here because this is kind of dead space. But I'm pretty sure that this is not big enough. So I think the answer is that the pump is going to end up being up here on top. So make some kind of a bracket to mount the pump, a bracket to mount the valve and the gauge, and plumb the thing all together. So here is my final choice of location for these various parts. The valve at the upper left, just mount an angle bracket. That'll be very easy to attach there. Alright, so from hooking up from the pump to the valve, I'm going to be using this brake hose. Bought this off of Amazon for $1.91 including shipping. It's rated at 4,800 psi. It's not a very large orifice, but I think for this purpose, the orifice won't be the limiting factor, let me put it that way. So on this end we have a 1/8 inch NPT, so I'm going to have to make an adapter to go from this, whatever this kind of hydraulic fitting is that the paint hose uses, from there into 1/8 inch NPT. And then I need an adapter to go from this same fitting, this is also a paint hose fitting, from there into this banjo. So first thing I did is I made a banjo bolt. It's a regular bolt that had a shoulder. I turned the face flat. I threaded it to I believe this is 3/8 fine thread. So I put 3/8 fine thread in this piece of steel so that the banjo bolt can screw in right here. And then I trepanned a groove in this face for an O-ring, and I trepanned a groove in this face for an O-ring. And that way this solid brass part gets squished between two O-rings. And then finally, I just trepanned a bit of a groove here and put a nice fat squishy O-ring there so that when this screws down tight, it squishes that O-ring in that groove. So this adapter is complete and I can put it together. Obviously I'll have to pressure test it, but I don't anticipate there being a problem. And then I need to go create basically the same thing. I'll do the same face groove and everything as here, except on this end I will turn it down to the same OD as 1/8 inch pipe and use a regular 1/8 inch pipe threading die to thread the outside diameter of it. I could have used, regular 1/4 inch pipe or whatever, but I would have had to have a union, and a 1/4 inch union can be tricky to find. This way, the banjo actually kind of acts as my union. Everything can be screwed together, and then as a final step, slip the banjo in place and tighten down the bolt. And besides, it was dirt cheap, so we'll see how it goes. So I just finished internal threading this adapter piece, 18 DPI. It's something like 17/32 by 18 DPI. It's this thread here coming off of the paint gun, and it's whatever a paint hose screws onto. I just matched it. So anyway, just finished internal threading at 18 DPI. Wanted to show you, I bought a couple of 1/2 inch pieces of high-speed steel a while back that I cannot find to save my life. So in a pinch, a broken drill bit makes a perfectly acceptable piece of high-speed steel. As long as this profile is correct, and I'm kind of trying to show you the 60-degree profile that's on this protruding point. As long as this profile is correct, it'll cut. Now it's not ideal because this surface is sloped. Instead of being flat, it's tilted. And so that kind of changes the way it cuts a little bit. But it actually did a fine job. And got it lined up here in the part. Screws right in very nicely. There's very little movement and wiggle. So I'm very pleased with that. And the seal will be right down in this crack, an O-ring that will seal the two faces together. And here is the other side of the adapter, which is, I misspoke earlier, it's not 1/8 NPT. It's actually M10 by 1.0. Little Google search revealed of what possibilities it could be, and then measuring this opening, I was able to determine that it has to be that. And I actually found it happened to have a fine thread metric 10mm bolt, which is to say an M10 by 1.0, and it screwed right in there. So this I was able to just use a die to thread this. So I turned it down to the dimension and then beveled this front edge a little bit because it looks like the intended seal is against that brass seat. So I eyeballed this bevel, and as you screw this in, that bevel will push into that brass seat and make the seal right there. And lastly, rotate the tool post around a little bit so that we can kind of cut a bevel so that this doesn't have any sharp edges coming up this tapered shoulder. And there you have the finished adapter. That end will seal up against the brass. This cutout here is to seal the O-ring against the face of the fitting on the paint pump. Alright, things have progressed well. I have the pump motor mounted, and I have piping. I chose to use this clear tubing so that I can see the fluid level. So from the bottom of the reservoir up into the intake of the pump. And this plug here acts as a kind of a fill port. Initially I had this priming return line piped in down here, but I realized that it's actually pretty easy to prime with this nice thick oil, and this is really superfluous. Now I'm not going to cap it off because this valve feels spring-loaded to me, and I think it provides a kind of emergency pressure relief. So what I'll do is just put a little tube here and just kind of route it to the back, and if ever it should eject through the pressure relief, it will just piddle fluid on the floor, but not a disaster. But this valve should really never be touched. Now when you have applied pressure and you want to release it, of course you just use the standard jack release. So the high pressure comes out here through this brake hose that I think I showed you earlier and into here, and then this valve serves to isolate the truly high pressure from the low pressure. And this hose and these fittings that I've designed, I'm perfectly comfortable at 3,000. But for the ram to hit 20 tons is actually something closer to 11 or 12,000. So that's why if you're going to use the hand pump, then you're going to close off this valve like so, and then start pumping. Speaking of the pump, I ground out the detent here. This is the old back of the pump. I ground out that detent so that it's not there anymore, and then just screwed in a number 832 screw that the notch in the handle engages in. So the handle works like it always did. You slide it down and rotate it over to engage the notch. And now to pump, you simply grasp here and pull down. The final thing is that I need to put these big springs back in place to return the ram back to position. And to do that, I'm going to be making a two-piece U-channel. So these two pieces here, when they come together, will be approximately the correct width to be able to return without hitting the side of the jack. and I will simply cut out these kind of U-shaped things, and then it can slide over like so and be bolted in place. Will be this two-piece channel that will functionally have a hole in the center. So I'll cut that out on the bandsaw. I'll use the eye bolts to connect this together. Probably wouldn't hurt to have an additional connector, say here and here, just to kind of get something up close to where the pressure is going to be at. And then put it together and we'll give it a run through. And there it is. We have the hydraulic pump mounted up high with the intake coming from the reservoir of the actual jack up through the intake, through the high pressure brake line into the cutoff valve. From the cutoff valve on down directly into the cylinder. So the way it works is pretty straightforward. You close off the cylinder. I made a replacement lever for the cylinder here so you don't have to use the handle over and over again. So it's just a piece of steel kind of cut to profile, drilled out to the same diameter as the bolt that sticks out of there, and then drilled for a roll pin. So it's closed is, you only need a half a turn, you don't need a lot of so closed is here, and then open is just over there. So you close it off. Let's say that we want to crush something. Hey, it looks like I have a Coca-Cola can. I'm not trying to impress you with its ability to crush a Coca-Cola can, but it is at least a demonstration that it can apply pressure while it travels. So there it is, more or less lined up. We just reach up here, make sure this valve is open, and hit the switch. And there it is. It's reached, what is that, about 2,800 psi. So it has just a pressure cutoff switch. It's pretty straightforward. So 2,800 psi, it cuts out. Now, I've made a little chart here to equate the delivered pressure versus the pressure at the ram. So right here, we're sitting at, what is that? Give or take 2,900, 29 and change. That's right around 5 tons of pressure. If we say that the press is capable of 20 tons, which I'm not sure would be a great idea, but if you really wanted to take it to 20 tons, then it's hard to read here, but it would be 11,737 pounds. So to take it up there, what we're going to do is we're going to close off this valve. So now the pressure is isolated. The pressure cannot backfeed into the pump. So now the only pressure is delivered from the hand lever. So if I sit here and apply pressure at the hand lever, you can see the gauge come up. So right there I'm sitting at right around 6,000. So 6,000 tells me I'm at real close to 10 tons right now. So if you need to really apply a lot of pressure, then you use the hand lever. But for most things up to about 5 tons of pressure, you just use the motor, and it saves a lot of time. And of course, when you're done, reach around here. And it comes back where it started. And our can, she is flat. A little bit of Loctite green, and there it is, final product, with the nice pump ball on the handle and a nice place to hang it. And voila, shiny red handle to pump with. That will increase its capabilities by a big margin. By the way, postscript, as long as we're here, you may be wondering what is the relationship with the press and this big aluminum cabinet. Well, it turns out that the cabinet is welding things. Heavy Miller welder on the bottom, plasma cutter on the top, and needs to be made neater and straighter, but there's basically where the welding stuff lives. This is on wheels. I don't have a lot of floor space, so the shop press, I made some hinges to attach the shop press, and when it's not being used, it folds over like so. It's kind of hard to get perspective in this small shop, but as you can see, it folded over against that cabinet. And I created a quick retractable foot out of some ready rod. So you can retract the foot, lock the cabinet in place, and this entire unit will fit out the door. So if I need to do a lot of welding, plasma cutting, I roll this unit out the basement door, do the work outside, and when I'm done I can roll it back inside. It's not ideal, but it's a small shop, so you do what you gotta do. And as always, thanks for watching. Piece of 1-inch Schedule 40